That's what I was trying to.
All right, guys. So I want to switch over into, we obviously in the video they talked about this invention of a type of concrete, right? And so the concrete enabled them to build very, very large structures. But I want to get into the specifics of the different wall systems and how they developed over time. There are a few of them, and so let's take a quick look at some of these things. So Romans essentially kind of started this whole idea of putting masonry together with this cement and mortar. Okay, if you look back at what the Etruscans did, the Etruscans piled very large stones dry one against the other, right? Some of those walls were called Cyclopean walls because they thought that it would take a cyclops to move those boulders. We saw the same thing in Egypt, and we saw the same thing in Greece, where the stones were cut and they were laid one on top of the other, right? The Romans essentially started this sort of thought of using a mortar to fit between the stones so that the stones didn't have to be so precisely cut. It acted as a filler in between the two, right? And from mortar, which was essentially made from lime, right, or limestone, crushed limestone, from mortar, they eventually invented that form of concrete, okay? So Roman concrete appeared in about the 3rd century BCE, and it was one of those things that kind of completely revolutionized the way that they built things and the size and scale of the things that could be built. Okay, it was essentially created by sort of mixing a variety of stuff together that was used initially to make mortar, right? But by adding that volcanic dust that was talked about in the video, pozzolana, right? The mortar actually created a chemical reaction, right? So there was a chemical reaction between the calcium and I believe it's the aluminosilicate that was in this volcanic sort of sand dust, okay? And when it created that chemical reaction, it literally molecularly bonded things together. And that's part of what made the strength of it, okay? Our modern concrete is about 10 times as strong as what the Romans had. Now, when we talk about strong, what we're talking about is something like tensile or compressive strength. But one of the things that's kind of interesting is that Roman concrete walls are still in use today. Roman harbors, right? The concrete from Roman harbors is still in use today. And so one of the things that researchers have sort of discovered is that we're still using the Roman walls in the ocean from 2,000 years ago with almost no deterioration, okay? But yet our walls are made out of modern concrete. After about 50 years, you start to see a level of deterioration of those walls. And so even though their concrete may not have had as strong a tensile and compressive strength, it had a durability that our concrete today doesn't have. So that's kind of just an important note. There are all these fancy words, right? Opus insurgam, opus reticulatum, opus testesium, and opus mixtum. That last one sounds like something like little kids would say when they're talking about mixing something. But at any rate, so we have a couple of images here that are showing the two techniques. One of them is more of a rendered colored image. The other one is just a drawn image. And so this opus insurgam, we would take a look at that one first. Okay, so it was introduced about the 3rd century BCE, and it used a series of just natural stones that were fitted together and then filled in the center with concrete. Okay, the way that these walls were built, they were built all at once. In other words, they were built, the concrete was poured and placed as the wall was being built. It's not like we do with cinder blocks today where we build the wall and then we fill it with concrete. So this stuff all went up kind of in courses and it worked its way vertically. Okay? So one of the characteristics of the insurgam is that it was made from just random stone patterns that were fitted together with mortar. Okay? And this is something that's substantially different than we see in Egyptian and in Tuscan walls, right? Where the stones had to be cut and fitted very precisely one against the other. These could be more random pieces that had the mortar in between them. That's the part I was talking to you about a moment ago. All right. The next one is opus reticulatum. All right. And opus reticulatum it came in around the 2nd century BCE, and it was made out of something called tuft. Okay. And tuft was a volcanic stone. It's actually, it's not a volcanic stone. It's essentially a sedimentary stone, right, that was from volcanic, like dust and sand. All right. So over centuries, the volcanic dust and stuff would compress and would turn into a type of soft stone. It's probably a little bit harder than you might find in pumice. You know, pumice you can just sort of scrape at, but it was shapeable. And typically it was shaped into these little cone blocks. And in some ways, you remember the walls that the early Mesopotamian Babylonians used to use, the Sumerians, had those little colored cones. In some ways, it's sort of like that, okay? Except that, again, this wall was constructed in such a way that it was built course by course and the concrete was added to the center, okay? One of the thoughts about this sort of, this invention of doing walls in this way is that it required less skilled labor to fit all those little stones together since it was more repetitive in nature, okay? And so the idea of it appearing at about the same time that there was an ample supply of slave labor might make sense, okay? So next one is here's an example of what those walls might look like. The next one we have is opus incertium. And opus incertium came into play about the 1st century, and it was made out of brick. Okay, so fired clay brick. And so it gave a much more even appearance, but the problem with brick was that it was inherently more expensive than just picking up rocks that you might find on a site. Had to be manufactured. Okay, had to be cut from clay. First the clay had to be processed, it had to be sort of shaped, and then it had to be fired. Okay, so that essentially led to this one that we call opus mixed. Well, actually, let's take a look at a couple of pictures of that type. One of the things about is it had a bonding course periodically. Bonding course would tie one side of the wall to the other side of the wall. So that's what that image right there is. All right, and here's a picture of what it looked like as a finished sort of surface. And then we finally get to the last one, which is opus mixtum. And the idea behind this type of wall is that at least one of the theories is that it combined sort of the best of both worlds. The cheapness of being able to just pick rocks up off the ground or put something in it that was relatively inexpensive with the notion of the brick. So it saved on some of the manpower. It had the best of both worlds. It would save, compared to doing it all out of a rock like that, right? It saved on manpower, but at the same time, it used materials that were expensive and cheap together to kind of bring the cost of the whole wall down. Okay? And so here you see a couple of images of those wall types. So you can see one of the things that I want you guys to note in these presentations is that there is this really broad variety of stuff, right? It's not it's not just focused on like one building type and one way of making. There's a broad range of stuff. And the second thing is that it seems to be consistent. And that comes from this notion of codification, of turning it into a set of written rules, documented rules that could be repeated over and over and could be exported to 3 continents and who knows how many current day nations, right? And still done in that same fashion. So one of the people that was responsible for that was a guy named Vitruvius. And Vitruvius wrote the 10 Books of Architecture. Sometime in the mid-20th century BCE, he put all of his knowledge down into these 10 books, and he dedicated them to, I believe, Augustus, right? Oh, right there, Emperor Augustus. So this work became known as the 10 Books of Architecture. It was saved from destruction when the Moors overran most of Europe. It was saved in a library. And so Vitruvius, from the very beginning, is this architect that tries to blend beauty and function, okay? And in that, he talks about, from the onset, we'll read off this thing, he incorporates the notion of integrity, strength, and function and beauty into one sort of common element. So I don't remember if at the beginning of our discussions on the first day we had this idea of commodity, firmness, and delight. Those are three Vitruvian sort of ideals, okay? And the idea of commodity means that it's useful, right? It's not just a piece of art that doesn't have any use. It's like architecture has to be useful. It's got to serve a function. Then he talks about firmness, and firmness you can translate into structural stability. Whatever it is, it's got to be durable, and it's got to be structurally sound. And then finally, the last one is delight. And delight is equated with the notion of beauty. Okay? And this is one of the things that distinguishes architecture from all of the general engineering fields, is that it is this uncommon blend of science and art. I mean, for the most part, you look at a lot of artists and they create a lot of what some people might call really fluffy stuff, right? And then you guys look at, some stuff that is done by engineers and they create very functional things, but they're not very attractive. Most of you guys, when you go out and buy a car, you're going to buy the nicest looking car that gives you the highest level of performance and is also going to be durable, right? Those are three traits that we look for when we want to go purchase an automobile or a phone. Think about that. Think about how that ties to the notion of commodity, firmness, and delight. Performance, right? Commodity means usefulness, so the car's got to be useful. All those things kind of tie back to these three thoughts. All right, Vitruvius had 6 methods of theory and practice, which he sort of labeled as ordinato, symmetria, I can't pronounce some of these things, disposito, right? Eurythmia, and decor. The 10 books of architecture essentially are his guidebook to architectural practice. And he did it at the end of his life when he was a very elderly person. So the 10 books of architecture cover these sort of 10 areas of science and sort of general topics. So there's town planning and architecture or civil engineering. There is the notion of building materials. So the 10 books cover these topics. Okay? There is this idea of the architectural orders, right, which we'll cover in the next class, which... Oh, do we pass?
No.
All right. I only have like 2 slides left. Okay, you know what? I'm just going to finish. So hopefully it stays under 15. So we got civic buildings. Ooh, where'd it go? It's not there. We've got the civic buildings, domestic buildings. So these are some of the sections that are in that thing. Pavements and decorative plasterwork. There is water supplies and aqueducts. Sciences that influence building or architecture, and finally, the use and construction of machines. Stop. Go. Where are you?